Okay, welcome to episode 4. What is a mesh? A mesh is a data structure to communicate shapes and forms. And those are basically just lists of positions. So that looks like this. A mesh is a data structure with vertices, edges, and faces, and the vertices is a list of vertexes, which vertices is the plural of vertex. And a vertex is a list of positions. And then an edge is a list of vertexes. You can pause here and kind of look at this in the context of the last video, but I'm going to dive in and try to build this up from the bottom so it's a little bit more straightforward. So this is your typical XY graph with a numbered x-axis down here and y-axis up there. And I got to turn on these lines so I don't get lost. Alright, so let's start out by putting down a point. And we are going to put it right here at 1.5 x and 1.0 y. And let me write that down as a list of floats. 1.5 comma 1.0. We're using floats because we're dealing with location slash position, and locations and positions are continuous, right? It can take on any number of values throughout here. So it's just a list of two floats. That's all it is. And we know from the context, because we put down a point, that it's this list of two floats indicates, the first one indicates our x position, and the second one indicates our y position. So that's also basically a vertex. And so let's express that by writing vertex. And that's going to be our label. And we're going to make this a struct, okay? And we'll do that. And so a vertex is a point that is part of a mesh. It's the most basic element of a mesh, and this vertex all on its own is actually considered a mesh. And so what that would look like is the mesh is a list of vertexes, or the correct term is vertices. So we will just label oops, I did something wrong there. Let me go back. I gotta leave a little bit of space for what we're gonna do next, actually. So our struct vertices, which is our list of vertices, which are lists of numbers, and then that is inside of a struct called mesh. And you don't need edges or faces to have a mesh. All you need is a single vertex, and that is a mesh. But we want to get a little bit more complex here, so let's add some vertices, and we'll put one at 3.0 comma 1, and we'll put another one at 3.0 3.0. And let me put those into our list over here, or rather our mesh data. And so we've got 3.0 comma 1.0, and then 3.0 comma 3.0, right? So each of these are just a list, but we want them to be part of a mesh, so we're gonna put them in vertex structs. I'm just gonna do vert for short, because I don't want this video to be super long. You just gotta keep in mind that each of these is just the struct for a single vertex. And put the bracket so we know the label and the list go together, and then put those inside the full vertices list. What I want to do is I want to label these actually, so that if I move them around or anything, I don't lose which one is which. So I'm going to put a 1 here, I'm going to put a 2 here. Actually, I'm going to number them from 0, because Blender and computers typically number things from 0. You might notice that this video series is numbered from 0. So 0, 1, 2. 0, 1, 2. Okay. So now we've got a mesh that is just a list of 3 vertices. The next thing we have are, the next element are edges. And I'm gonna do this backwards so that we have room. I'm gonna use my straight line tool here. So I'm gonna put in an edge here. And an edge is just a line segment, a straight line segment drawn between 2 vertices. And so that is identified actually by the vertices. Now remember I numbered them. That's called an index. And we can use that to keep track of them on their own, but also we can use them to identify edges. So that edge is a list, 0, 1. And you'll notice that we're not using floats anymore. These are integers, because you can't have a half vertex. You aren't going to have like a half point anywhere. Either you have a point or you don't, because a point's just like a location. You could have a point at a location halfway between 2 other points, but that would just get its own number and own struct. And so this is going to be called edge. And we're going to put quotations on there so we know that that's a label, and we'll stick that label with the list inside of a struct. And then that is going to go inside of a struct called edges, which is a list of our edges. And I don't need to change the color for the quotations. I think you guys get the gist. All right, but then I want this to be a triangle. So I'm going to add edges between my other vertices. And you can have a mesh with just one edge. That 2, we take that out. This on its own here is a perfectly valid mesh. Even though the 2 isn't connected, it's part of a list of vertices. So you don't always have to have stuff connected to be part of the mesh. The only bar is just that the data that represents the point is included in the list. And you can't have an edge without having, you can't have like a floating edge on its own, because it has to connect vertices that are in the list. So we'd have to have a vertex here and a vertex here to have an edge there. Anyway, so let me go in and put in the other edges. And so there's an edge that connects 1 and 2, and an edge that connects 0 and 2. And we will add those to our list. I want them in green to make it a little bit clearer. 1, 2, and then 0, 2. And put some brackets to show that structured numbers, which are data, and I'm going to add my edge label to each of these. And so you might wonder, well, why do we have to put each edge in a struct? Why don't we just have these lists on their own inside of this edge list? Well, that's because if we want to deal with one of these on its own at some point, without the context of being inside of the mesh and the edges list, then having that label right on top of that list is very helpful. And that'll kind of be a little bit more clear once we get into how Blender's using them. So let's formalize that, and let's bring our mesh bracket all the way down. And I don't have room below. I'd like to make this fully vertical, but I can't do that. So I'm going to introduce faces over here, and I'm going to start a face. Just a single face. what's it called? Face struct over here. And a face is a filled in, whoops, I want my purple color. A face is just a filled in polygon. And a polygon is a shape with 3 or more straight connected edges. It's like a square, a triangle, pentagon right there, I think. No curves. Curves are just achieved by, like here you can see this is more curved than the square. You just add a lot more straight lines. And once you've got enough straight lines, a lot of them, then from a distance it looks like a curve. So that's how you achieve curves. There's no like real curves. They're all just combinations of straight lines. So let's go back here. And so a face, in terms of the data, is kept track of just with a list of the vertices that it's connecting. And so we do, I need to be in one of green. It's 0, 1, 2. Again, we're using the indices from the vertices to identify our face. And so this is just a list of integers, but we put it into a struct with the label face, and now it's easier to interpret what these 3 integers mean. They are the indices of these vertices, and we know that, okay, that's where a face goes. And you can have, before we had this face in there, we had a triangle, but it wasn't filled in. Being filled in or not is going to make, hopefully make sense now. If it is not straightforward enough yet, once we get into Blender, that'll be a little bit easier to follow. And so this face is in a faces list, because we could have, we only have one in this example because we're just doing one triangle, but we could have a lot of them. And I'm going to number it 0. We're not going to really need the indices for these, but I just want to make them because in Blender, all these lists, they've got indices. So that's a triangle mesh. That's pretty much it. We went over polygons. We went over how things don't need to be necessarily connected. The next thing I want to go through is that you've kind of got 2 examples of a mesh here. You've got this one, which is the drawing, or the I think the term I want to use is visualization. And then over here, this is the data. This is the real mesh, if you will. The mesh is the data structure that we use to communicate this shape. But if we're trying to communicate this shape in the most universal way, we want to just use these labeled lists of numbers. That's way more universal than trying to pass around a drawing. If you want to get this triangle over to somebody, you could draw it on this grid, but you could just then that would be one way to get it to them. But maybe they want to recreate it like giant on the side of a building somehow. This is the more universal way. You would give them the list of numbers, and then they can reconstruct the visualization all on their own. That's actually what Blender is doing. People tend to think they're interacting with what they see, and they think that's the mesh. Really, it's just a visualization. And the real mesh is the data that Blender mostly keeps behind the scenes. But we are going to go ahead and we're going to get into that in the next video and talk about it a little bit more. The only other thing I want to do is just mention that there's different types of mesh files. There's like .obj and .stl and .fbx. .blend is Blender's native one, which actually contains the whole Blender scene, but sometimes meshes get passed around as .blends. And then there's a .3ds for 3ds Max. All of these are file formats, and they all contain this data. They just structure it in different ways, meaning like the order can be a little bit different, or sometimes instead of faces being lists of vertices, the faces might be lists of edges. And that's where these indices will get used, and instead of the integers here being lists of these indices, it's lists of these indices. And so that's usually pretty much handled on the back end. I'm just mentioning that for some of you might get into the programming side of it, so you'll want to be aware of that. All right, see you in the next video.